Hi everyone. In this video, we are going to be starting with the problems. So first one is parking load system design, LLD. Let's start with the requirements. So as we have already discussed how we are going to perform our system design LLD interviews. If you haven't watched the video, do watch it. But let's start with it. So starting off with the requirements. So the parking lot should have multiple types of parking spot like accessible, compact, large, motorcycle. Second requirement is parking lot can have multiple entry and exit points. Should support four types of vehicles: car, truck, van, motorcycle. Should be multi-level, so there can be multi-level parking. Each level should have a display board showing number of available parking spots for each parking spot type. When parking lot is full, no vehicle should be allowed and there should be a clear message on the board. So there is some sort of a display board here. Okay. Users will be getting the parking ticket on entry, which will be used to track parking time and calculate payment receipt at exit. Right. Configurable pricing for type of vehicle and for parking spot type and different rates for different duration. Like first our X price is fixed and then for further hours there can be Y price. Right. So you can keep the base price a bit higher than the hourly price. Payment receipt can be accepted via cash, credit card, or UPI, any of those methods. Now, starting off with the entities of the system, the first entity is entry gate. So we have entry gate, exit gate. We have the parking lot itself. This is the main class, main sort of the system handling all the parking things. So assigning spot, unassigning spot, telling if the parking is full or not. It has pricing policy and all of that. Then there is a level. So each parking lot can have multiple levels, multiple entry gates, multiple exit gates, right? This we will look at in more detail in the UML diagram, but for now I will just go over the entities. We have level. We have the display board on which you will show number of parking spots available for each parking type, and if the parking is full, then you can display something there. There is parking spot, which refers to one particular slot of parking. There is parking spot type, which is an enumeration, and same for vehicle type. Vehicle is an abstract class. Vehicle is abstract class that contains vehicle type and license number. So a vehicle can be car, truck, van, motorcycle. So all of these are actual implementation of the vehicle abstract class, right? Next one is ticket. So ticket contains your information about your parking, and then we have the payment type, which is an enum of cash, credit card, or UPI. Then we have the payment class itself that will handle the payment part. Then we have the pricing policy, which contains the rate card. So rate card for each vehicle for uh, fixed rate as well as variable rate for each hour, right? And it will calculate the price given the ticket. So these are entities of our system. Let's move on to the UML diagram now. So this is our UML diagram. I'll start with the parking load since it is the main class. So a parking load contains of levels, entry gates, multiple exit gates. There is pricing policy, parking lot instance. So this arrow that you can see that is pointing to itself is the instance. Since the parking lot class will be singleton, because we do not want multiple instance of the parking lot, right? The parking lot will contain some functions like is full. If the parking is full, it will have a function to assign a spot, unassign. So in unassign, you'll get the ticket and payment type. You'll have ways to add entry gates, exit gates, add a level, right? All of those sort of the thing you can do from the admin panel or something. But for simplicity, we are not having the admin flow here in our LLD. We are just talking about the user flow. Right. So we have an entry gate, which contains an ID just to identify which entry gate it is. We have a parking lot and a generate ticket function. So whenever someone comes in the parking, they go at the entry gate, they tap some button or like come to the gate, and the generate ticket will be called with the vehicle. So vehicle will contain all the information about the vehicle, like its license number, its type, and all that. And you will get a parking ticket here. Now, same we can look on the exit gate as well. It also has an ID and a parking lot instance. The reason we have parking lot instance is we want to call methods on the parking lot right here. So your entry gate, exit gate is mainly with which you will be interacting uh, from the user perspective. Okay, so we have process ticket. You give the ticket and the payment method, and you get the payment receipt. Then you can make the payment, or you can handle the payment inside it, which is what I have done. You just get the receipt at the end. The receipt contains string ID, amount, what is the amount you have paid, local date, timestamp. So this is just a timestamp for logging when this customer paid. There is payment type as well. So payment type is cash, credit card, or UPI. Next, we will move on to the pricing policy. The pricing policy contains a map of vehicle type to a map of integer and double. So integer will tell me hourly price, and double is the price itself. So the rate card contains the price, and you can pass in the ticket, and you can get the price based on the how much time they have spent in the parking. Right. So now next we will move on the levels. Right. So we can see there is composition here. Parking lot contains level. So level in itself is nothing without a parking lot. Right. That's why it's a composition and not an aggregation. Okay. So here we have the level. In the level we have floor number, which floor uh, this level is on. We have parking spots. So based on the parking spot type, for each spot type, we have a list of parking spots. We have a display board on each level, and the display board in itself consists of a number of parking spot available at each sport type. So sport type is an enum of accessible compact large motorcycle. You can update the uh, display board by passing the number of parking spot type to a list of parking spot which we have kept here. If you will just pass this update here, it will update the number of this available sports map, right? And you can print. So print will show the details about your level, right? Now we have a parking spot in here. So first cover level. So level has a method called add spot, which takes in a parking spot. You can add parking spots. So this is like an admin would do. They will add a level, add multiple entry exit gates, add parking spot of each type. Then we have is full to check if the level is full or not. Then we have park vehicle, where you can just pass in the vehicle and you will get a ticket. So this is the user flow, I think, if you understand. Park vehicle, update board, right? All those functions. And then we have parking spot. So inside parking spot, we have a string ID. We have Boolean for free if this parking spot is occupied or not. We have the type of spot it is. So type of spot, if you see here, it will be somewhere around or not. But like we mentioned it here, parking spot type is accessible, compact, large motorcycle, right? Any of those. So in the parking spot, we have all these things, and the methods are the important part. So one is can fit. So if it is a motorcycle, or if it is a car and the parking spot in itself is of a motorcycle, then it can't fit. It will give you a false or true based on that. Then you have an assign function. You can assign this parking spot to some vehicle and you'll get the ticket back. And then there is free. Is this parking spot free or not? Just a method to check that. We are not exposing it. So we are having our encapsulation. So 4 pillars of OOP that we have studied, we are implementing those. Right. And then we have the get type to get the which type of spot it is. In the level, we have covered these functions. Then we have the ticket itself. The ticket contains ID. So that is just a UUID. We have the vehicle, parking spot, and the levels, right? Which level this is parked on, and then the local date time. So entry time we have, and get duration in hours will give you how much time you have parked in for. That you can calculate by subtracting now and the entry time that you entered in. Right. So this is mostly covered. We have the pricing policy, and yeah, I guess we have covered the UML diagram. Now we will be going to the code itself. So I'll start the code with parking load driver. And inside the parking load driver, what we have is we have first initialized a rate card here. So in the rate card, what we have done is we have a rate card of type vehicle type. So for car, for hourly rate or for fixed rate. So this is the fixed rate is 30. 30 is your base price. So no matter if you park for an hour or you park for like 2 hours, the base price plus hourly price will be added. So for rest of the hours, so in order to mark or store the hourly price, I have used a special index here just to say -1. So here what I've done is -1 refers to your hourly price. So inside map you have the key -1 and it will be 20. So 20 rupees for vehicle type car is your hourly price. Same for a truck and for a motorcycle, right? Then we create a parking policy. The parking policy in itself will take in a rate card here inside the constructor, and it will have a calculate function. So in calculate, you will pass on the ticket, and you will be getting the price or the amount, right, that the user has to pay for their parking. So let's cover this part. We have the duration in hours. So on ticket, you can call the function duration in hours that will give you the duration between your entry time and now, and you can convert it to 2 hours. So I've used duration dot between. Right. And what else we have done is if I go back to my if I go back to my calculate function, we got the duration, we get the rate card of so the type of vehicle it is. So based on that, we will get this map of integer double, right? This is our base price. So rates dot get 1 on 1 we have stored the base price. And what we have done here is simply that maximum of duration in hour. So if someone parks less than an hour, so the duration would be 0 in that case, and 0 minus 1 is negative. So we don't want a negative here, since that can make our price go to negative. So we have taken a math dot max. So maximum it can be 0. So it will be always positive. That is what we have done here. And then we have multiplied the hourly price. So for first hour, your price is this. And then for subsequent hour, your price is stored on -1. Right. So we have multiplied it by that. I hope this is clear. Next, we will move to the driver again. So if I move on to the driver, right. So this is clear. Now we'll move on to creating a parking lot and passing in the pricing policy. So the parking lot has a constructor where you can just pass in the pricing policy, and all of these will be initially empty, like level, entry gates, and exit gate. There are functions to add entry gate, add exit gate, or add a level, right? Okay. So again, if we see this thing, we create a parking lot. We create an entry gate now with a random UUID and a parking lot instance. So if you check the entry gate, inside the entry gate here, what we have is a constructor that takes an ID and a parking lot. It has a generate ticket method, which we have seen in the UML. So the generate ticket will take a vehicle. So a vehicle comes to the entry gate and say, give me the ticket. If the parking lot is full, that is why we have kept the parking lot instance, since we are calling this assign spot and your generate ticket is full. If we are checking that parking lot is full or not. So if parking lot is full, we just throw an exception saying parking lot is full, illegal state exception. Then we return the ticket itself here. So ticket comes from assigning a spot. So if we go to the assign spot here, what we do here is pretty simple. We do a stream filter. So we filter all the level which are not full. So levels dot stream dot filter all the level where level is not full, and just find the first level that is not full. So we are not iterating. So it will like cut off at the time when we get a parking level which is not full. We do not have to traverse after that, right? Now we will check. So this is find first returns us an optional. right? So in order to handle this optional, what we have to do is we have to check if it is empty or not. If it is empty, we just say illegal state exception or levels are full. So there might be concurrency cases where you would get that the parking is not full here because at the time it was not full. There are multiple entry gates, some other vehicle entered through some different gate, and as a result parking is now full. So you will have to check it here as well, right? Right, so we get the parking level via the get function, and then we do a park vehicle call on that. So level dot park vehicle. Inside the park vehicle, we pass in the vehicle for all the parking spot type. What we are doing is we are checking if it is free and the vehicle that we have can fit or not. And if it can fit, we assign the vehicle the spot. So we do an assign. We return the ticket, right? And we mark this as is we this slot is now not free, or this parking spot is now not free, and the vehicle assigned to this parking spot is this one, right? Okay. Next, what we will be doing is, so we return the ticket, we update the board. So in update board, we just just send in the spots, and for each parking spot type, you can then compute the number of available spots by checking if it is free. So filter with free, and you can put it. You can update that map. So this map consists for this spot how many available parking spots are available, right? So that is what we are updating here, right? So this is done. Next, let's move on to some other flow. So if I go to the driver again, we have created the entry gate, we have added the entry gates, we have added the exit gate, right? It is same here. Then we have our display board, which is we have a level one. We have added some parking spots on level one, like accessible, compact, motorcycle, large, right? And we have added this spot to the level, and we simply update the board after that. We add this level to the parking lot. Now we run the code here. So this is the user flow. A vehicle comes with the number 123. We generate a ticket via the entry gate. So entry gate dot generate ticket. We have seen this flow. Now this is your exit flow. So if we come here, payment receipt dot. Okay, so this exit gate dot process ticket. Let's see at this particular piece of code or flow. In the process ticket, we have the ticket and the payment type. Payment receipt we will get from the parking lot. So we call the unassigned function. Inside the unassigned function, we have the ticket and the payment type. So via the pricing policy, which we have seen, the calculate method, we will fetch the price. We will create a new payment receipt. So it will have an ID, which will be a UUID, price, the time, and the payment type, right? And we will also update the board here, right? And this ticket level update board we have called, right? So during the unassign, what we also want to do is on the parking spot, or let me just check. We have the assign function here, and then I'll create another function here called unassign. So for unassign, what would we want? So we assigned this spot somewhere, right? So we said this parking spot is not free. So unassigned would simply make this null and this is true. It won't return anything. So this is what will happen. And I'll just call this thing here. So what we have here. So we have ticket dot level dot unassigned. Okay, so on level I would want an unassigned function, and then I can probably unassign it. So on ticket I have the level. Let me check if on ticket we have the parking spot, right? We do have the spot. So we can say ticket dot spot dot unassign, right? This will free up the parking spot, and then we will update the board. So this was missing, I think, from my part. We do an unassign, and then we update the board, and we give back the payment receipt, right? So this is what happens. And now what we can So we have covered this flow of unassigning as well. Let's just try to run this piece of code since I've made some changes. I'll run this piece of code. What I get here is I can check. So this is your display board status. On large, you have one available spot. On compact, you have one. So one spot for each type, and this is the board. Here is your parking ticket, and after giving a parking ticket, what we can see here is on large you have one, on compact you have one, accessible, and motorcycle is also one. So yeah, after uh, giving a ticket, here we can see that compact becomes 0, right? Because we have given that parking spot to that particular vehicle, and after we have unassigned it, after they have done the payment, the display board is updated here and we get that parking spot back, and they have made a payment of 30. So yeah, that is the case. So this is all about the parking load design. I hope you have understood it. If you have any doubts, do comment in the comment section. Thanks a lot for watching, and do subscribe to the channel. Thank you.